Hi guys, in this video I explain exceptions. I first go over an example that does not use exceptions, and then I demonstrate how we can introduce exceptions by implementing an exception class and adding a try-catch block. Let's go over the example. I have two prototypes defined. The first prototype is named divide. It expects two integers as arguments and returns an integer value. The second prototype is called readInt and it returns an integer value. Now both of these prototypes are implemented below the main. The first function here has a single statement. It performs integer division and returns the result. The second prototype reads in an integer value into the val variable and returns its value. In the main, I declare two integer variables named num1 and num2. Both I initialize to the return value of each readInt function call. So both of these are initialized with user input. I then pass both values as arguments to the divide function. This performs division, I get back the quotient, and then I output the arithmetic operation with the num1 value, num2 value, and then the result, the quotient. Now let's run this program. I enter here 10 and 5, and this outputs 10 divided by 5 is 2. Now I run this again, and I output 4 and 0. Now this crashes the program. It gets an arithmetic exception because we cannot divide by 0. It is undefined. Now a naive solution would maybe be adding a if statement, check if the denominator is 0, and then simply assigning 1 to the denominator. Now when I run this again, and I use the same input values of 4 and 0, we get a result 4. But this is not really the right result. We actually performed 4 divided by 1. So this is not ideal. We could add a condition in the main, but if we have a very large program, this would not be ideal too. There could be so many function calls, we would not be able to trace it. So the real solution here is adding exceptions. I start out by implementing an exception class, and I name this class divide by 0 exception. Typically for exception classes, you give it an explicit name that describes the problem and then a suffix named exception. This publicly inherits from exception. I add the semicolon to mark the end of the class. Now I also add a public function. This returns a character pointer, a string. This is called what, and I add the const throw keyword at the end. This now returns an exception message that better describes the exception. So here I return cannot divide by 0. Now with this implemented, I now have an exception that I can use in the program. And the way I use it is instead of assigning a new denominator, I want to throw this exception here. So I throw divide by 0 exception. I call the constructor, it creates a new object of the exception class and throws it. Now we always throw an exception when the regular program flow cannot be performed. In this case, we cannot continue with our function, we cannot continue the program flow. So we are using an exception. This is the ideal case. Now if I run this again, let's see what happens. I enter 4 and 0, and I get now a message terminating with uncaught exception of type divide by 0 exception. Cannot divide by 0. So we successfully threw the exception, but we didn't deal with it. So we have to catch the exception, what this points out. So exceptions are thrown and they are caught. They are caught with a try-catch block. So I put a try keyword here around the block that I want to handle. In this case, I use both statements. It is thrown in the divide function, but I also cannot use the quotient if I don't know what the result is. So I use that statement in the try-catch block as well. So try-catch block is always around the code that is critical, our critical code here that we want to perform. Now I use catch keyword followed by parentheses, and inside the parentheses I write the class name of the exception and an identifier. Now what this will do is it will call the divide function. If it successfully determines the quotient, it will output it, and then after this it will continue here. So I put the end, and the catch block would be skipped. Now if the divide function throws an exception, it would match the type to the exception type here defined in the catch block. If it matches, it will enter the code block here. And here I can output a message. Exception caught, and I call the what function to get more detailed about on the exception, and I output this. So let's run this. And again, I enter 4 and 0 as input. And here I get the message now. Exception caught, cannot divide by 0, and then the end. The end is really could be any other part of the program that might be able to execute even though an exception occurred here. So this is the proper way. We declare an exception class with the what function that returns a description of the exception. And then wherever we need to throw it, we throw the exception and we catch it. Now there could be multiple exceptions thrown. And we can handle multiple exceptions by adding additional catch blocks. So here we could add a catch a generic exception, for example. So there can be multiple catch blocks, 2, 3, as many as we need. It would first try to match it to this type. If it doesn't match, it keeps checking. Similar like an if condition based on the type. The other thing to know is if the divide function calls additional functions. Let's say instead of this statement, there are multiple functions calls. Each of these functions could also throw an exception. Now we could add a try-catch block around each of these function calls. But if we don't, if there's no try-catch block around it, it will simply continue throwing the exception further up. So that the nested call here that would be in place of this statement would throw it. There's no catch block inside the divide function. It will continue throw it until there's a catch block that can handle it. So this as an introduction to exceptions. I hope you enjoyed this video. Thank you for watching.